from the unit circle. Is that still fresh in your mind? Are we still okay with that or no? All right. So you saw this question on that unit circle, and at the time we just said, what do we say? That this means cosine of some angle equals a half. On the unit circle, that hopefully we're borderline pros in, cosine means the what value? Perfect. The x value. So where is the x value? A half. So if I draw this vertical line, I'm saying that is x equals a half. And it happens at this angle. And at this angle. You don't have to do the sound effects. Are we okay? We haven't done anything crazy yet. What is this angle right here if I go like that from the x-axis? In radians. It's 60 degrees, but in radians it is. So that's one of them. And what if I go from the x-axis and I go like this clockwise? Well, it is 7 pi over 3. I mean, it's, sorry, I say 5 pi over 3, but I don't want that answer. I went clockwise. Did you say negative? Oh, no. Oh, I hope I didn't give an answer away. Negative pi over 3, because I went in a clockwise rotation. Is anything crazy there? Okay. How do you say this cosine to the negative 1? It is not a reciprocal. It is called inverse. So you either say inverse cosine, or you can also use the word arc. Arc cosine. They both mean the same. So when you talk to your professor, you're going to say arc cosine or inverse cosine. Are we still okay? Nothing crazy, right? Okay. I want you guys to notice something. Well, I guess we'll notice as we continue. There are formulas. I didn't write them. I copied and pasted them. Here are the formulas. Relax, guys. They all come from somewhere. And this year we're just going to focus on cosine, cosine, cosine. And then once we've mastered cosine, we'll do the inverse sine or arc sine. We'll see how if this is just an adjustment. I think you guys will have an easier time if we just focus on one. All right. Notice there's a plus minus. That plus minus came from here. See how we got pi over 3 and negative pi over 3? Now, if you were to type in cosine of pi over 3 in your calculator will spit out 1/2. So take your calculator. Do you guys all have a calculator in front of you? All right. So check it out, guys. Now, the calculator is just a machine. It's not all that smart. Oh, look at all that fun stuff. Okay. Second memory 712. Sorry, I didn't pass out a calculator to everyone. All right, check it out, guys. Cosine, and I'm going to put pi over 3, and I'm going to push enter, and I get 0.5. That's what we wanted. Yeah, I thought I had a calculator in every desk. My apologies, guys. Cosine, negative pi over 3. And notice I get that 0.5 again, that half. Are we okay? I want you guys to observe, if I do arc cosine of 0.5, that's that inverse that I told you about, the calculator is dumb. It's not going to tell me plus or minus pi over 3. By the way, this 1.04 is that pi over 3. See, look, pi over 3. But we know that negative pi over 3 is also an answer. Does that kind of make sense to you guys? Okay, now here we go. Here's what I want you guys to really, really understand. There is an infinite amount of angles that will give me 1/2. So how would I find the other angles? Tell me what you think when you see this one whole revolution there in green. I have to add what? Like if I want another angle that also gives me 1/2. So right now I know this. Chav, what are you asking? I know that cosine of pi over 3 is 1/2. I know that cosine of negative pi over 3 is 1/2. What if I want another angle? I just did this here in green, and I end up back in the same ray. Yeah, because why did you say 2 pi? Yeah, a whole revolution is 2 pi. So if I just add 2 pi to that pi over 3, won't I get another answer that also gives me a half? Yeah, so look, let's take the pi over 3, and I'm going to go plus 2 pi. Guys, and it's really simple. I just take that 2, and I turn it into a 6. Chav, what are you doing? Why? The denominator was a 3, so 6 divided by 3 is 2. Yay or nay? Yeah, you can say nay if you don't understand what I'm doing. Okay. All I'm doing is adding 2 pi. Chav, why are you adding 2 pi? Sit in the back, please. I'm adding 2 pi because I want another angle that also gives me a half. I haven't gone anywhere, guys. Look, I'm still in this blue ray. If I add another 2 pi to it, I'm still there. Does that make sense? So 6 pi plus pi, that's 7 pi over 3. That's an answer. Now check it out. If I take my calculator and I write cosine of 7 pi over 3, do you get a half? Yeah. Now the calculator is dumb. It doesn't matter how hard I try. It will never give me this one down here in quadrant 4. It will never give me negative pi over 3. So that's why we write plus minus in the front. Cool or not cool? So if you're wondering, I know some of you already know this answer down here. That's 5 pi over 3. But you could have gotten it from just going negative pi over 3 plus 2 pi. Look, negative pi over 3 plus 2 pi. I'm going to turn that 2 to a 6. I'm going to turn the denominator to a 3. Child, why are you doing that? I'm trying to add 2 pi. 6 divided by 3 is 2. So negative 1 plus 6. What's negative 1 plus 6? 5 pi. And look, 5 pi over 3 is the angle that you guys already knew in quadrant 4. Are we okay? All right. This is where this 2 pi n comes from, guys. That n stands for how many cycles you have done. How many cycles? It's an integer. N is an integer. And that's why they tell you there where n is an integer. Notice they put plus 360n if you're in degrees and 2 pi n if you're in radians. You guys aren't usually this quiet. You guys usually have more questions. Hit me. What are we thinking about right now? Okay, so you get it? Okay, perfect. All right, here's our first test. Are you guys ready? I want the first 5 positive values of arc cosine a half. So I'm going to write arc cosine of 1/2. And we're going to do it just with brute strength. This is just the example we just had. I'm going to start at x equals 0, or my angle equals 0. The very first one, where cosine is a half, is at what radian? Pi over 3. Good job. So here it is. I'm going to say this is x. X equals pi over 3. That's my first one. What's the next one? I know you guys know the next one. What is it? No. Of the first 5 positives. 7 pi over 3. Okay, what's the next one after that? I think we might have even did it. It's up here. Yeah, it is. It's up there. Oh, look. I did a mistake. I wrote 7 pi over 3. It's not 7 pi over 3. Which one's 5 pi? And then 7 pi. Yeah, that was a mistake on me, guys. I didn't do it on purpose. All right, what's after 7 pi over 3? Take this guy here and add 2 pi. So 5 pi over 3 plus 6 pi over 3. What's 5 plus 6? So this one has to be 11 pi over 3. Don't worry, we'll do it another way. So we got the fourth. We got 4. How do we get the fifth one? Take which one? And I'm going to add 2 pi. I'm going to add 2 pi to that. So what's 7 pi over 3 plus 6 pi over 3? 13. How do we feel? Do we feel okay? All right. I want to make sure that we understand what's going on, guys. Okay, let's do an algebra 2. Let's do it how you did it in algebra 2. This is one of your methods. Remember when you were in algebra 2, remember what this means. This means cosine of some angle equals a half. When you were in algebra 2, you did this. This is one of your methods. You went to y1 and you typed in cosine x or cosine theta, and then you went to y2 and you typed in a half. and then you graphed them and you saw where they what? Intersected. And those values, so according to this, if you do this method with algebra 2 method, you should get these same values here. Is that making sense to you guys? So let's try it out together, because this is going to be an important skill that you're going to need. So take your calculator, go to y equals, type in cosine x. On y2, type in a half. Are we still okay? Click on window. X min, type 0. X max, I'm going to be doing 2 revolutions. So let's see, 4 pi. Let's go add a little more to that. Go to 6 pi. 3 revolutions. Y min, negative 1.2, a little bit below 1. Y max, 1.2, because the amplitude is 1. I want to see the wave. Push graph. Ask guys. What's up? The window? Did you get a graph that looks like this? Okay. These are my first 5 values, guys. 1, 2, 3, 4, 5. These are my first 5 values right here. Let's see. Okay. This calculator is just a tool. There's got to be a way to tell this calculator to find my intersection. Do you see a button on the calculator that says calculate? Do you see a button that says calculate? Yeah, it's right where the trace button is. Do you guys see that? So push second trace, and these are all the commands that the calculator can do. Which one am I going to look for? Intersect, number 5. It's going to say first curve. You only have 2 curves in there. Enter twice. First curve, enter. Second curve, enter. It tells you the red one, or mine is red because it's colored here. And then it's going to say the word guess. When it says the word guess, go to the one you want. So I want this first one way over here, so I'm going to move the cursor like this. See? Yeah, don't worry. I'm going to come to you guys. And then I'm going to push enter. And it needs to say the word intersection. So try that out. If you need help, let me know. Go to the one you want. Say the word intersection. Yeah, perfect. Enter 2 times. It says yes, go to the one you want. And see how it says yes, go to the one you want. Guys, how are we doing over here? You got it, guys? Does that say the word intersection? Well, that way you can see a little better. Negative 1.2, 1.2, and then do the same thing. You got it? Yeah. All right, guys. I think we got it down. It just takes practice. There is another way. I'll show you another way in a little bit when we get more advanced. Uh, you see that intersection 1.04719776? That is pi over. That is pi over 3. Check it out. If you go to the home screen, I'll go to the home screen for you because you probably don't want to mess with it. Second pi divided by 3. Oh, look, it's right there, right there. 1.04719. See? So that second one, that second answer, the 5 pi over, what was it? 5 pi over 3 there. That is this one down here. And I bet you that's that second answer. Now, okay, let me go back to my graph. I just want to make sure that we're clear on this. No matter how hard you try, when you do inverse cosine of a half, the calculator is always going to give you this answer. It's not going to give you this one. So how do I get this one? From the negative pi over 3 plus 2 pi. See? And then the period of cosine is 2 pi. So this one repeats every 2 pi. Does that make sense, guys? Yeah. And then this one here, that's the same thing. It repeats every 2 pi. How do I get that answer? From the negative pi over 3 plus 2 pi. That's that 5 pi over 3. Look, watch. Check it out. Get that intersection again, guys? Look, I'm going to do this. We're going to practice a lot, guys. Second, calculate number 5. And I'm going to go enter, enter. And I'm going to scroll. See, I'm going to scroll to the one I want. I want this one. Make sure it says the word intersection. See, 5.23598. That is 5 pi over 3. If I take my little calculator here, and I'm going to go second quit. And look, 5 pi over 3. And look, we get that 5.235. Isn't that cool? Second, calculate, 5, enter, enter, enter. How do we feel? Are we feeling okay? Have we done anything crazy? Are we okay? Okay. Okay. Here we go, guys. So we just answered our first one. Flip the page. Now, I don't have a perfect radian. Now it doesn't have a pi in it. So look, it says find the first pi positive values of arc cosine of negative 0.3. So we're going to try it two ways. So we're going to use our skills that we just learned. Let's try it first by graphing. So I'm going to try it first. Remember what this means. This means cosine of some angle equals negative 0.3. So we're going to try it first by doing this. Go to your y1, and you're going to type in cosine x. So you already have it. And on y2, instead of a half, I'm going to put what? Negative 0.3 or negative 0.3. So let's do that. So window y equals, change your y2, clear it, negative 0.3. I guess, you know what? Mr. Winters would probably be mad at me, so I'm going to write negative 0.3. There. Winter probably wants that 0 in front of the decimal. All right, here you go. Graph. We are getting the first, which ones? The first 5. So someone give me my first intersection. This table over there, one member give me my first intersection. This table, one member give me the second intersection. This table, one member give me my third. I'll give you the fourth. Second, calculate intersection. Enter. 1, 2, 1, 2, 3, 4. 10.690882. I didn't get the fourth one. 1, 2, 3, 4. Yeah, that's the fourth one. 10.690882. All right, table 1. What is my first intersection? What is it, Chavez? No. Tell me. It's okay. It's a safe space. If we're wrong, it's okay. 1.804. Give me one more digit. 7. How many digits after the decimal? Always, always, always? At least 3. The more, the better. The more, the better. At least 3. All right, table 2. Give me the second intersection. 4.407. Give me one more digit. 6. Truncated or rounded. It's all good. All right, table 3. Give me the third one. 415.8. That's fine. All right, there's my third one. Here's my fourth one, and I'm gonna get my fifth one. Second, calculate 5. Enter. Scroll to the fifth one here. 14.44186. 14 point. 8 point what? 8.1586. Okay. 14.44186. 14.44186. All right, those are my 4 digits. How do we feel so far? Not crazy, right? Okay. We're going to go slow. Let's do it algebraically. I'm going to change my colored pencils here. So if you have colored pencils, it is a good one too. All right. I'm going to go slow, guys. I'm going to go really slow. So this arc cosine negative 0.3, I'm going to rewrite it like this. X equals, and I'm going to put a plus minus, because remember we have the positive angle and the negative angle. And I'm going to write arc cosine or inverse cosine of negative 0.3 plus 2 pi n. Why am I writing the negative there? Because the calculator, no matter how hard we try, will never give us that value. Will never give us one or the other. It's only going to give us the positive angle. Are we still feeling okay, guys? Okay, here we go. I take my calculator, and I'm going to go, where's the inverse button? So first, let's go to the home screen. Second, quit. So I'm going to clear all this so you won't see a whole bunch. So the inverse button is right here. Do you see it where it says cosine negative 1? Where the cosine. So you got to push the second button and push cosine. And there it is, cosine negative 1. It's not a reciprocal. And then in here, I'm going to write or type. What am I going to type? Negative 0.3. Enter. And there it is, 1.875488. So I'm going to write x equals plus minus 1.8, I already forgot it, 875. 875,488. Okay. 488 plus 2 pi n. Okay, so it looks like we're going to have to check this one, or maybe I just wrote it wrong. It's close enough, but it's not the exact. So let's go really back to my graph and make sure that it says the word intersect. Second, calculate number 5, enter, and then when it says guess, you're going to hover over it. See, so I'm going to go back to the first one, making sure. And be careful because, see, sometimes you think like, oh, look, there it is. That's my answer. It needs to say the word. What word am I looking for? Intersect. So push enter, and there it is, 1.875489. So let's change the very first one here. It's 1.875489 or 488. We'll verify that one in a little bit. All right. Here's what I think is easiest for you guys. Turn this into 2 general equations. That's what it's called, general equations. So I'm going to write over here. I'm going to go x1, and I'm going to use the positive one. Don't worry, we're going to test you guys right now to see if we're good. 1.87548 plus 2 pi. 2 pi n. And then on x2, instead of the positive one, I'm going to do the, what am I going to do? The negative one. Negative 1.87548 plus 2 pi n. How are we feeling so far right now, guys? All right, let's put them in order from highest to lowest. Relax, we're going to go slow. You guys ready? The very first one I see is on this one, 1.875. So I'm going to write 1.87548. We're testing to see if we're going to get these numbers right here. The second one, where's the second one going to come from? From x2. I'm going to take this number and I'm going to add what to it? Yeah, perfect, 2 pi. You can say it loud, guys. Don't be embarrassed. It's a safe space. Here we go. I'm going to put negative. I'm going to scroll up. I'm going to push enter. Do you guys see how I put the negative in there? And I'm going to go plus 2 pi. Enter. Look at that. 4.40769. Did that match perfect? 4.407. Yeah, it did. Good job, table 2. Not that table 1 is, good job, table 1. All right. How am I going to get the third one? Add 2 pi to which one? To the negative or to the positive? To the positive 1.87. So I'm going to take my calculator. I'm going to scroll up to the 1.875. I'm going to push enter. I'm going to go plus 2 pi. Enter. 8.1586. 8.1586. Let's see. Table. Yep. Good job, table 3. How do I get the fourth one? Add 2 pi to which one? The 4.4 or the 8.1? Yeah, the 4.4, which is coming from x2. That's like saying n equals 2, guys. So I'm going to go to 4.4, scroll up, and then push enter, and then go plus 2 pi. Enter. 10.69088. 10.69. 10.69088. Did we get it right? Yep. And then the last one, which am I going to take? And I'm going to add what to it? 2 pi. So take the 8.158 and add 2 pi plus 2 pi. 14.441. 14.441. And there it is. How are we feeling, guys? Are you feeling okay? Okay. Let's continue. Don't freak out. Don't freak out. All right. In a little bit, we're going to give you a question that's from an actual math competition in 2019, where I don't know. We'll talk about it in a little bit, guys. So here it is. Here's a question. So let's say this is a question for your entrance exam at the University of Boston. I'm just making it up. This is a very real question that they can ask you. How would I solve it? How would I do it with a calculator if you have one? What do I do? Chav, I don't know. It looks complicated. What would you guys do in Algebra 2? What did we just do a little while ago? Yeah, we just typed this into our calculator. Can't I do the same thing? Yeah, tell me what am I going to type? What am I going to type in Y1? Tell me, guys. Tell me. What do I just type cosine? Or Yes. 7 cosine 2 pi over 13 x minus 4 close plus 9. That's what you type in Y1, guys. On Y2, what am I going to type? Yeah, say it loud and proud. Yeah, that's the AP score you want. Yeah, don't you want a 5 on your AP exam? Okay. Are we okay? Type that in, guys. Go ahead and take your calculator. Go to your Y1, and you guys are going to guide me. Give me my equation. 7. Give me the equation, guys. 7 cosine. I'm going to use the alpha for the fraction here. 2 pi over what? 13. And then I'm going to open a parenthesis. What do I write? X minus 4. Close it twice. And then what do I write? Plus 9. Okay, what do I write on Y2? Yeah, I heard someone say it. Say it again. 5. All right. Before you push graph, guys, this is a super important skill here. Make sure that you know how to mess with the window. Click on window. And here's how you're going to do it. Look at where they want the value. Solve with a calculator of this on the interval. Look at the interval that they give you. That just means x is a subset between -7 and 27. So that -7 is your x min. So you take your calculator and you're going to go x min, -7. Enter. X max, what do you think you're going to type? 27. And then x scale by 1, that's fine. Chav, how do I find the minimum though? All right. Ready? The midline of your sinusoid is 9. What is 9 minus 7? Because that's the amplitude. What is it? 2. So I'm going to go a little below that. I'm going to say like 0. And then I'm going to go to y max. And now what is 9 plus 7? And I'm going to go a little above that. So I'm going to say what? Yeah, 20, 18, 19. They're all good numbers. And then there it is. I'm going to push graph. And now I can see my sinusoid and I can see that intersection. How are we feeling? Did it look like that? Okay, let me see. Okay, if it doesn't look like that, guys, check your equation. Well, you haven't typed in your equation. No, you type in this equation. This. That's the equation we're using. Does your graph look like this? Okay, everyone's looks like that? All right. Table 1, can you get me that first intersection? A different person. Table 2, can you get me that second intersection? Table 3, can you get me that third intersection? And I'll find the fourth one here. Second, calculate. First curve, second curve. 1, 2, 3, 4. Help your partners. I'll write it right here. All right, table 1. What'd you guys get? 4, 2, 4, 9, 1, 5. Thank you, Chavez. All right, table 2. Liberty. Miss White. Yeah, that sounds good. That sounds good. Table 3. Besides Ramos. The third intersection. It's 1, 2, 3. Oh, maybe that's the third one. Oh yeah, the second one should be. You want to try? You gave us the third one, Miss White. So thank you for the third one. But let's get this second one right here. It should be a negative number. All right, what is it, Miss? Negative 0.5084 6. Like that. Okay, and Lanto, what was number 3 again? 8 point or okay. The fourth one is 1, 2, 3, 4. Enter. 12.4915. 12.4915. And then finally, the fifth one. Actually, there's 6 answers. Second, calculate 5. Enter. Write this number down, guys. It is, you're going to get 2 more. 21.508469. Write that number down. That's the fifth one. 21.508469. All right, Liberty, help me out here. How do I get the sixth one? No, you're just going to help me? So what do I push? Tell me what to push. Second, trace. 5. Enter. Good job. 25.4915. 20. I already forgot. Give me the fifth one. The fifth one and then the sixth one. 21.51508. And then what was this last one? 20. Yeah, 25. Short-term memory. 25.49. Was it 49? 4915. 4915. Okay, we got them all. How are we feeling? We're feeling okay? All right. Okay. Yes, that's what we're about to do. All right. Yes, ask. Like the very first, like X1, X2? You can think of it like this. Okay, actually, I'm really happy that you asked that question. What's the period? Okay, let's do some previous knowledge. Looking at this graph right here, you see that 2 pi, 7 cosine 2 pi over 13? Looking at the 2 pi over 13, can you tell me what the period of this graph is? Yeah, tell me what the period of this graph, the blue one. You think it's 12? We know this, guys. That's your B. The B tells you your horizontal dilation or stretch or compress. Remember how we calculate our period? The period should have been 2 pi, but it's 2 pi over 13. So it's not 8, but you're close. How do I calculate the period? So then what's my period? The period is 13. I don't want you to be a robot. The B is always 2 pi divided by period. These are just general formulas. I don't want you to be a robot. Remember from your algebra days that the B tells you a horizontal stretch or compress. And remember how we factored out that horizontal stretch or compress? This is your factor. You just take the reciprocal of it to see your scale factor. So the period should have been 2 pi. Take the reciprocal of 2 pi over 13. 13 over 2 pi. OMG, look, the 2 pi's cancel out. So the period is 13. Could you use a formula? Yes, you could have gone B is 2 pi over period, so 2 pi. So that means the period is equal to 2 pi over B. And yeah, you could have gone 2 pi divided by 2 pi over 13. And what's the common thing that they tell you guys? Keep, change, flip, 13 over 2 pi. Yeah, you could have gone it with a formula. But guys, if you understand what's going on, you don't ever need formulas. Because, the formulas are just meant like, here you go, here's a cop-out. I'm not saying it's a cop-out, but all these formulas are derived from somewhere. If you understood that the 2 pi over 13 is a horizontal dilation by a scale factor of the reciprocal, you don't need any formulas. Okay, I'll stop. Sorry for preaching there. All right. So to answer your question, Ms. White, the period was 13, right? And you said, how do I know which one is which? So you see this one, this curve is decreasing. So if you find this point right here, let me go to the board here. If I find this intersection right here, this is the intersection with this curve decreasing. Notice this intersection here, the curve is increasing. If I add 13 to this one right here, this will give me this other one because it repeats every 13. Does that make sense this way? So how do I get this one here? I add 13 and I get this one. So, did I answer your question? You can say no if I didn't. So there's 2 points. These are the two main ones that you want to get. I'm not saying that the calculator is going to give you this one and this one. The calculator is only going to give you one, but remember the plus minus? Are we cool?
Yes. So say you put in the wrong scale. How would you find the value?
Yeah, if you put in the wrong scale, if you are off, well, the scale's not going to matter, but if you put in the wrong Y min or Y max, then you're not even going to see this red line. You know what I mean? But my scale's by 1, but it doesn't matter what the scale is. If you increase the scale on your window, it's just going to give you more of these little lines. Does that make sense? So we can do it really fast so you can see. So if you have your scale here, look, window. I'm just going to mess up with the scale. What do you want me to put the scale? 0.2? It's just going to put more little, see? But if you mess up with the Y min, Y max, it's possible that you'll get it out of frame. So you got to just make sure that's what's important. Your Y min, Y max, X min, X max. How do you figure out your Y min and Y max, guys? You look at the midline and you look at the amplitude. The midline plus amplitude is your high. The midline minus amplitude is your low. And that's how you figure out the window. Cool or not cool? Okay. All right. Ready for some algebra? Okay. Guys, don't worry. We'll be fine. Let's start off. Now we're doing it algebraically, guys. So here we go. Let's start off by writing the statement 7 cosine 2 pi over 13 x minus 4 close plus 9 equals 5. All right. What are you going to do? What is your task? To solve for what? Yeah, so I need to solve for what variable here? X. So what is my first move? Subtract 9. Yeah. Minus 9, minus 9. Does everyone agree that that's the first move? All right, so here we go. Write the statement. 7 cosine 2 pi over 13 x minus 4, close, equals the difference between 5 and 9 is 4. The 9 is larger, so keep the negative. Negative 4. Are we okay so far? All right, what's my next move? I have 7 times cosine. Divide. Perfect. Cosine 2 pi over 13 x minus 4, close, equals negative 4/7. What's my next move? Yeah, that's where we get stuck. What's my next move? What? I gotta get rid of the cosine. How do I do that? Okay. No. There's a learning point. It's okay. Cosine, you can't divide by cosine, guys, because this is cosine of this. Does anyone know what quote unquote this is called? It starts with the letter A in the math world. No. Second letter R. You might know. Third letter G. Argue. Hey, Lonnie. Argument. That's your argument. This in the math world is called an argument, guys. It's the same thing as f of x. Look, you're not going f times x. It means f of x. So f is a function of x. So this is your argument. All trig needs, all of them require an argument. LNs require an argument. So this is not, you can't just divide by cosine and the cosine goes away. It's cosine of all that stuff. That's called an argument. Cool or not cool? Good job, miss. So I can't divide by cosine. How do I get rid of cosine? Okay, so time out. We're gonna yeah, you got it right. But I don't know if okay. Side note. Yeah, I'm sorry guys. There's so many things going through my brain right now. All right. Side note. Put a side note. What if I told you that you cannot divide by 3 to solve for x for that stuff in purple? How would you do it? If I told you can't divide, you would either tell me, oh, well, then I guess if you can't divide, then I'm going to go ahead and multiply by the reciprocal of 3. Or because it's a number, you can call it the inverse of 3. So you would go times 3 to the negative 1. That's called inverse or reciprocal. It's just a number, so it's fine to call it. Whatever you do to one side, you do to the other. So times 3 to the negative 1. And look, you would get the right answer if I take my calculator and I go, so here's my calculator, second quit. I want you guys to see this. Clear, and I'm going to go 15 times 3. And then you see that little button that says negative 1? Boop. And look at that. It gives me my answer. Because that's the same thing as saying 1/3. Laws of exponents, bring it down. So it's the same logic. So there it is, guys. It's the same logic. So, but cosine doesn't have, well, it does have a reciprocal. The reciprocal is secant, but we're not talking about that. Same logic. What are we talking about? So what do I got to do to get rid of that cosine? I got to take the inverse. Good job. So when I take the inverse, I'm going to write 2 pi. Oh, let me go back to red. So I'm going to write 2 pi over 13, parenthesis x minus 4, close, equals, plus minus arc cosine of negative 4/7 plus 2 pi n. Did I confuse anyone? Please tell me. Ramos, how do we feel?
Alright, I was just trying to figure out what the equation was from, but like I know.
Yeah. Remember that it repeats every 2 pi. Your parent function repeats every 2 pi. So, and I mean, I really don't want to be that teacher that says it's part of the formula. Remember, we derived the formula. There it is, right here. I'm just mimicking that. We know the 2 pi because of every revolution. The plus minus, because the calculator is not going to give us the negative angle. It's only going to give us the positive angle. So there it is. Cool or not cool? Ah. Guys, you feel okay over here? For sure. Okay. What's my next move? I'm trying to solve for x. What's my next move, table 1? Man, I really wish I could get that x by itself, but I can't do that right now because I'm multiplying that 2 power 13 times x minus 4. I really got to get rid of that 2 power 13, but what do I do to get rid of it? What did I do? Yeah, you can divide. You can divide by 2 power 13. The only problem with that, I mean, it's not a problem. If you like this, then that is fine. But notice it looks kind of ugly. So what's better? Okay, but this is a number, so I can call it what? Start letter R. The reciprocal. So I can multiply this by, let me change the color so you can see, by 13 over 2 pi. Whatever you do to one, you do to the other. So I'm going to go slow because here's a very confusing part sometimes. So there it is. And now look what I'm going to have. And I'm going to go slow, guys. X minus 4 equals, I'm distributing the 13 over 2 pi to both of these. Bam, bam. You don't have to do the sound effects. Plus minus 13 over 2 pi arc cosine of negative 4/7 plus, and I'll slow down, the 2 pi's cancel out, and I just get 13n. Are we okay? Look, I distributed, the 2 pi's cancel out, and I just get 13n. We are so close. No, this is x minus 4. Add 4. When you add, don't put it to the very back. Write it right in front. Yes, that way there won't be any errors. In front of the plus or minus. 4 plus minus 13 over... Yeah, ask. You're about... I'm going to ask why it's positive. Yeah, we have the plus minus there because... Why do we have the plus minus there?
Because, no, that's not... I know why. I was asking why the 4 was positive.
Oh, to move it to the other side. Yeah. We are so close, guys. Yeah. Why do we put it at the front? Why did I put it in the front and not the back? How all your other teachers have told you. All your other teachers have told you, just put it in the back. Plus 4. Why? The most common error. Yeah, tell me why. The 13n is a period. Oh, I don't want to say an answer. Okay, what? The plus 4, put it in the front because some of you guys are going to put plus 4 back here and you're going to combine like terms and you're going to think that 13 goes with the 4 and you're going to add them up and it doesn't. Or this is just a number and some of you guys forget to add that 4 to it. So if I put that 4 in the front, that mistake never happens. Because it's 4 plus, I mean, if you know what you're doing, then you're always going to do plus that with that 4, the negative that with that 4. But to make life simpler, put it in the front, and then you don't have to worry about it. Cool or not cool? All right, here we go, guys. X1 and X2. These are called general equations. We're almost done. I know, these are tough. I'm going to get one of them by doing the plus. I'm going to get the other one by doing the minus. Caution, word of caution, when you're typing this into your calculator, use the fraction feature of the for the 13 over 2 pi, like this. 4 plus, push alpha, push y equals, push enter. If you have the newer calculators, you can just push alpha and then the x. 13 over 2 pi. Okay, follow along, guys. Do you have that much? Okay, type in, what is it? Arc cosine. So arc cosine, second arc cosine of what number? Negative 4/7 or 4/7? Negative 4/7. Negative 4/7. This one's okay for not to look like that little fraction. Alpha y equals, yes. All right. Does yours look like this? Do not put the plus 13. Push enter. Hopefully that's a number that we got earlier. Do you guys see it? 8.508. 508,468. 508,468. 508,468 plus 13n. How am I gonna get the second one, guys? Oh no, not yet. The add 13n is for like what did the different. How do I get x2? How do I get the number? I just did 4 plus. How do I get the other one? 4 minus. Scroll up. You don't have to type it again. Scroll up, push enter. That's the beautiful thing about these calculators. You can just scroll up and then just change a plus to a minus. Boop. See? Negative 0.508. What are these equations called again? Not everyone at the same time? What are those equations called, guys? General equations. Why are they called general? Because those equations will get you all the answers. No, ask. We're almost there, guys. We're almost there. X equals blank negative 0.508, comma. I'm just going to put 3 digits. All right. How do we what? You don't type in. Mm-hmm. I want my next answer, negative 0.508. All right, guys, focus. 8.508, comma. Then the next one, I take the negative 0.508 and I add what to it? 13. So I'm going to take my calculator. I'm going to go plus 13. See? 12.491. Don't worry, I'm going to do it again. For the next one, I take the 8.508 and I add what to it? Yeah, I want the next one, the next answer. I got negative 0.508, 8.508, 12.491. How do I get the next one? Add 13 to 8.508. 8.508 plus 13. Enter. 21.508. How do I get the last one, the 25.491? Take the 12 and add 13. I guess you can just go 12 plus 13. There it is, 25.491. Hold on, don't 25.491. I'm missing a number. How do I get it? Subtract from what? Yeah, from which one? The 8.508 subtract 13? Yes, you're right. 8.508, take the 8.508, scroll all the way up, and subtract 13. I guess I can just take this guy right here and just change the plus to a minus. Bam. Take that plus, change it to a minus, and there it is, guys. Negative 4.491. Negative 4.491. How do we feel? Okay, we're almost done. I know. It's brutal. I know. Okay, check it out. I got a question for you from a math competition, and it's the same math competition that we went. It was from UH. It was from 2019. It's on the last page. I should have typed it in, but here it is. I'm gonna give it to you guys. 2 cosine 3x minus pi over 4 equals negative square root of 3. And the domain was 0 to pi over 2. And they had this question on that UH math competition, and you had to do it without a calculator. And that year we came out, and they were like, Chav, I couldn't do it without a calculator. I needed a calculator to solve this one. And I'm like, man, you don't need a calculator for every question, guys. Though you know how to do these questions. You just don't know that you know how to do them without a calculator. You guys ready? No, look, we're going to hit you. I'm trying to solve it in a good, not like that, guys, you know. All right. I'm trying to solve for x. I want all my answers between 0 and pi over 2. We're going to go slow. If you were at this math competition, what would be your first move? Divide by 2. Look what happens when you divide by 2, guys. Cosine of 3x minus pi over 4 equals negative square root of 3 over 2. As soon as you see that, hopefully there's some red flags going on in your head. Is this a perfect radian when I do the inverse? It is. Where is cosine? Look, I'm going to draw a unit circle. Where is cosine negative square root of 3 over 2? Right here at this quadrant and in this quadrant. Give me the radians. The denominator is a 6. 5 pi over 6. What's the other one? 7 pi over 6. See, this is why we give you those unit circle quizzes, guys. So look, inverse cosine. I'm gonna write. Well, we're gonna get rid of that cosine, right? By doing what? I kind of said the answer. Inverse. So here we go. 3x minus pi over 4 equals, and I'm gonna write plus minus arc cosine of negative square root of 3 over 2. That's a 3 plus 2 pi n. You're not gonna need it. And I'm gonna write equation 1. And even though I wrote plus minus, we'll come back to that in a little bit. Where did you say we have a negative square root of 3 over 2? At what? So that's what I'm going to write. 3x minus pi over 4 equals 5 pi over 6 plus 2 pi n. Equation 2. 3x minus pi over 4 equals, what's the other one besides 5 pi over 6? 7 pi over 6 plus 2 pi n. All right. And relax. I'm going to go back to equation 1. I'm going to move the pi over 4. 3x equals pi over 4 plus 5 pi over 6. Are we still okay, guys? I'm going to find a common denominator. Don't worry, I'm slowing down. I see a 4, I see a 6. I'm going to multiply this dude by 2 over 2. I'm going to multiply this dude by 3 over 3. My common denominator is 12. Yes. 3x equals 3 pi over 12 plus 10 pi over 12 plus 2 pi n. What's up, Lowry? No, please ask me. No. Okay, where did I lose you? And then, so like right here? All I did, you see this negative pi over 4? I didn't move to the right. So whenever you move something to the right of that equal sign, you have to change the sign. So I added pi over 4. See? So pi over 4 plus 5 pi over 6. And then what I'm doing, you see all this stuff in green? I'm finding a common denominator, which is 12. Between these two, pi over 4 and 5 pi over 6. Perfect. Yes, 3x equals 13 pi over 12 plus 2 pi n. Last move. What do I got to do? Divide by 3. All right, guys. Divide by 3. When you have a fraction, put the 3 next to the 12. See? You already divide by 3. Here's my answer. 13 pi over, it's like keep, change, flip. It's like keep, change, flip. Just put your 3 next to the 12. Okay, I'll do it here on the side.
Oh, wait, no.
No, I'll do it.
I get it.
13 pi over 12 times 1/3. Just put the 12. See, put the 3 next to the 12. You know what I mean? No, please ask. I'm sure there's others, so ask. Always ask. 13 pi, what's 12 times 3? 36. That does not reduce. Plus 2 pi n over 3. Oh, wait. Does that reduce? No, it doesn't. What's up?
Why did you make it 2 pi n?
Say it again.
Why did you put 2 pi over n? Like, instead of doing just 1?
I don't know what you mean by instead of just doing 1.
Because if you're just doing 13 pi over 12 by 3, it's like it would be 13 pi over 12 times 1 over 3. So why did you replace the 1 with the 2 pi n?
Oh, I didn't. The 2 pi n was already there originally from way back here. I thought you were initially asking like why I didn't do common denominator there. But no, the 2 pi n was already there, and I just did divide by 3 everything, right? So I never did anything with the 2 pi. I just left it there, and I divided by 3. Now notice, I do want you to notice something about the 2 pi over 3. 2 pi over 3 is larger than half a pi, so it doesn't even come into a play because it's not part of my domain. If I were to add 2/3 pi, I'd be outside of it. And definitely 13 over 36, that's definitely smaller than half. right? Did I answer your question? Because there's nothing. So 2 pi is right here, right? 2 pi n, and then when I divided this by 3, I divided everything by 3. So the 2 pi n was always there. So 2 pi n over 3. Cool or not cool, guys? All right, let's do one more, the blue one, and then we'll take a short break, and then we'll continue on our math journey. What do I do with this? So tell me, what do I do with that? I'm trying to solve for x on the blue one. What do I do? Move the pi over 4. So 3x equals pi over 4 plus 7 pi over 6 plus 2 pi n. See, the 2 pi n is there, Miss White. What do I do with the pi over 4 plus 7 pi over 6, guys? I'm going to find a common what? So I'm going to multiply this one by 2 over 2 and the pi over 4 by 3 over 3 because my common denominator is going to be 12. So then I have 3x equals 3 pi over 12 plus 14 pi over 12 plus 2 pi n. The 2 pi n is still there. What's 14 plus 3? 17 pi over 12 plus 2 pi n. And then last move, what do I got to do? Yeah, so you're dividing by 3, everything. And there it is, guys. You think you guys can do this question on the math competition? Say yes. The answer to this is 13 pi over 36 and 17 pi over 36. Now, I gotta make sure to tell you guys this. If you find it really hard to navigate the calculator, there is something that you can navigate really easy that you guys have been using that starts with the letter D. Do you guys remember? It's an application on the web, Desmos. I just gotta caution you, when you hit the university, they're not gonna let you use Desmos. They're not. It's not web based. I have several professors that I speak to, and the ones that I talk to like all the time, Dr. Becky George at Georgia Tech, she tells me that there is no, like, she doesn't let. It's a paper exam still, and that's Georgia Tech. UT does paper exams as well. Now they do homework online, but exams are all still at the moment paper. Okay. All right, take a 1 minute break, guys. Stretch out really quick. Yeah. All right. Go ahead. Yeah.
Thank you.
Hey, Rotary, do you wanna? We'll help you. There you go. We're gonna help you. No worries. We're gonna all guide you. We're doing number 1. We're gonna do it together. Read the instructions that it says out there for us.
For questions 1 through 3, find the first 5 positive values of the inverse circular relation if a perfect radian leave in terms of pi.
Okay. Is the first one perfect? Gonna be a perfect radian? Square root over 2? Yes. What's the first angle that has cosine b squared root over 2? Power 2, you're close. Power 6. So right power 6.
Just like, okay.
What's the next angle? That's square root 3 over 2. It has a 6 in the bottom. In quadrant 4.
5 pi. Oh, in quadrant 4.
Yeah, because in quadrant 2.
11 pi over 6.
But let them guide you.
My bad.
Why 11 pi over 6?
Because that's where we're talking about. That's where it has square root of 3 over 2 in the fourth one.
Yeah, what coordinate? The x or the y?
What?
What coordinate is square root 3 over 2? The x or the y?
The x.
Good job. Making sure we had a good job, Miss White. Happy birthday. All right. There's more. It says the first 5 positive. How do I get the next one? How do I get the next one? Yeah, tell them, man. What are we gonna do?
Add 2 pi.
Yeah, well, we're not gonna subtract because we want the first 5 positive. So we're gonna add what?
6.
To which one? To the power of 6 or the 11 power of 6?
The power of 6.
To the power of 6. Good job. So 2 pi, the denominator is 6. So my numerator has to be, if I want to add 2 pi, I'm gonna add 12 pi over 6. Does that make sense? Because 12 divided by 6 is 2 pi. What's 12 plus 1? There it is. Alright, comma. No, yeah. Okay. Yeah, let's do it. How do I get the next one, guys? Add 2 pi to which one?
11.
To the 11 power 6. Good job. So what is that? 12 plus 11?
22.
12
No,
plus
it's not.
11?
23.
12 plus 11.
12 plus 11. 12 plus 10 is 22. Plus 1 is 23. 33? I don't know, guys. Whatever. So what is it? 23?
Yeah. 12. 23. 23 pi. You're right the whole time. Okay, how do I get the next one?
2 pi to 13.
Plus,
13
so what
power
do we
of
get? 25 pi over 6. Good job. Yay. What do you guys think? Cool or not cool? All right. Don't worry. We'll take care of one more. What you guys consider tough. We're gonna do that one right there. You think you can do it?
Yes.
Who wants to? You got a volunteer that wants to take care of letter A? We'll guide you.
Yes, let's go.
Oh, Mister, I don't think I'm tall enough for this.
All right, so you're just doing letter A. Read letter A for us.
Particular equation of the, how do you say that?
Yeah, sinusoid.
Sinusoid. You can use cosine for all of them.
Okay, so what that means is I want an equation for that sinusoid, the one that's going up and down. And we've done that many times, right? So write the general form, y equals a cosine. Do you know what I'm talking about?
Yeah.
Just go down the alphabet.
Equals a cosine.
Open parenthesis again.
Yeah.
X minus c. Close D. And this is the first time you guys are doing this. So good job. All right, here we go. What's the easiest one to find? Maybe the midline. What's the max? So write D equals. What's my max, guys?
All right. What equals?
D equals.
Oh. D equals
The max is
7.
7. So write 7. What's the minimum?
-3.
So 7 plus -3. Because that's the midline. D is the midline. Divided by what?
Divide.
Yeah, that's how you find the middle, right?
Oh.
I mean, I guess you could have just looked at it, but.
7 plus 3 is 10. Divided by 2, that's 5. So you count 5 spaces.
That sounds like a lot of. That sounds like more work to me. Well, okay, that's fine. She's finding, but that's not the midline. That's the amplitude. 7 plus -3 divided by 2.
Yeah, that's the amplitude, but then you draw the line.
Yeah, and you said 5 spaces down from 7. You would have gotten the same answer. 7 plus -3, that's 4, and 4 divided by 2 is 2.
4 and then 2.
And let the record show that Miss White said 7 minus, what did you say? 7 minus 5?
7 plus 3 divided
Oh, yeah.
by 2 is 5.
So let the record show that Miss White said 7 plus 3 divided by 2 is 5, so that's the amplitude, so you're going 5 down from 7.
So 7.
7
Oh my
minus
god.
5.
7.
7, okay. Perfect. That's what Miss White said. No, we're going to use radian, guys. Regular radians. There's not a little degree on the x-axis. All right, so we got the A, we got the D, we need the B, and we need the C. So how do we get the B? Peak to peak. So I have a peak at
3.
at 23, and I have a peak at 3. So what is the period? 20. Good job. So right period equals, and then do what they said. So 23 minus 20. Yeah. All right, and then write B equals. How do I get the B? Okay, so 2 pi over 20 over 10.
Oh, shoot. Oh. Sorry, guys.
All right,
I can't hear.
All right, give me the equation. Y equals?
We don't have C.
Oh, yeah, what's the C? What's your peak?
3.
3. Yeah, 3 to the right. Okay, all right, Y equals?
5 cosine.
Yeah, everything looks good to me. 5 2 plus 5 is 7. 2 minus 5 is -3. Yeah, I think we're good. Good job. Cool. Travis, do you want to use the calculator or help us with the calculator? No, don't worry. Won't guide you. You're just you're good with the calculator. You're the one that gave me intersections. Remember? So come on now, come on. You gotta help me. Come on, we're gonna guide you. We're gonna guide you. Girl. All right, guys. Letter B says find graphically. Take your calculator. You did it last time super perfect. So minimize this. See the little middle?
No.
Yeah, look, take this guy. And then push the minimize. Okay, there's my calculator. Click on Y equals. So we're finding it with our graphing calculator. So we give Miss Chavez the equation, guys. What's the equation? Oh,
Wait.
yeah,
Maybe
just go to
wrong.
the left. It's just like the regular calculator. And then push, yeah, alpha Y equals. Answer. What's the B, guys? Power of 10?
How's it go down?
Yeah, it takes longer with the calculator. Keep, do another, go to the right one, another. Okay, X minus 3. Close. Okay, and then go to Y2. What does it equal? What am I supposed to equal? 6. Okay, click on window. It says right there. And then on window, what's the smallest X value? I'll put -3 for X min. What's the biggest X value? No, like 29. X scale, make it by 1. Just put 1. What's the smallest Y value? So put like -4. Is that a negative?
No, it's not negative.
Perfect. And then go to Y max. What's the biggest Y value? 7. So go like to 8. Okay, push graph. All right, Chavez, show us how to find the first intersection.
That one?
Yep. Look at that. Man, like a boss. You did good.
Boom.
All right, 9516. Write that down, guys. That's the first intersection.
That's
You
all.
want- Yeah, you know what? Go ahead and find the other 3 for us. You're just doing the same thing over and over. You got it. There's 4 answers. So Chavez is going to go ahead and get you the other three. Eventually, I'm going to have TVs hanging up from the ceiling. So we'll be able to watch many. $5.0483. Make sure we put that one down. Oh, for Chavez. Yeah. We got all four. You're only going to do one more. So you got to get the fourth one.
Oh.
Push enter.
Wait. Oh.
20.9516. Thank you, Chavez. You got the pen? You left it there? All right, guys. You guys get the last one.
No, not you.
Hey, you-
What was that one that she has her
20.9516.
And the last one is.
I don't know. You guys got to get it.
Do you want me to tell you?
Nah, it's okay. All right, letter B. What were the answers, guys? 0.95167, comma 83, comma
20.9516.
comma. Let me guess. Let's see if we can guess just by looking at this. 25.0483. How did I do it without graphing? Did I just memorize the answer? How did I do it without graphing, guys? I added. Why did I add 20? Because that's the period. Yes. This doesn't work. Sometimes it works, sometimes it doesn't. It shows it's on full blast. Sometimes it works. Let me see. Because sometimes it does work. Yeah. No, well, no. I put the volume all the way, but sometimes it just chooses not to work. So, but no, after school it works sometimes. It's the mornings that tend to. Happy birthday yet? Sorry. I didn't mean. I didn't mean it like that. I promise. Just love. Okay. Letter C, last one. All right, guys. Focus, focus, focus. We're almost done. Find the algebraic values. You don't have to do it all by hand. I just want the general equations, and I know when you add 20, you're going to find the others. That makes sense? So look, just go like this. Go 5 cosine parenthesis pi over 10 close x minus 3 close plus 2 equals 6. What's my first move? And I'll put it in blue to make sure. Minus 2. So I'm going to write 5 cosine pi over 10 parenthesis x minus 3 close equals 4. What's my next move? Yeah, divide by 5. I'm trying to go kind of fast because we're getting pretty close. Cosine pi over 10 x minus 3 close equals, you guys told me divided by 5, right? 4/5. There it is. And then, close. How do I get rid of that cosine? No, don't say multiply. Just say either arc cosine or inverse cosine. So here we go. Pi over 10 x minus 3 close equals plus minus arc cosine of 4/5 plus 2 pi n. Okay, now we're going to multiply Miss White. What am I going to multiply by? What's up?
So anytime you do the arc cosine, that's when you include the divide.
Yes, always. What did I do, Miss White? Okay, you can say that. Divide by pi over 10. But what did we remember? We said we could also Perfect. 10 over pi. Whatever you do to one, you do to the other. So here are my two general equations. All you got to get to is to here, guys. X1 equals, well, I guess I still have that minus 3. X minus 3 equals plus minus 10 over pi, arc cosine of 4/5, plus the pi's cancel out. What's 10 times 2? And that's how you can verify if you're right or not. The period is 20, so you better get a 20n. All I got to do is move the what? The minus 3. So how do I do that? Just put it in front. All right. What do I do next? Write two separate equations. All I'm checking is to make sure that I got one of those as one of these answers here, because I know plus 20 will give me the other ones. So I take my calculator and I'm going to go, you guys tell me, what am I going to type in my calculator? What did I type in here? 3 plus 10 over pi. Second, our cosine. And what I type in the inside of this? 4 over 5. Don't tell me that's a bill. Oh my God. Yeah, don't do that. Just do that. Don't worry, guys. Give me a little bit of time. 5.040483 plus 20 n. Hold on, guys. Hold on. How do I get the other one? And yeah, the minus. So 3. Or just don't do it again. Just go on the inside. Take that plus to a minus. And we got that 0.95. Do you guys see that? 0.95167. This is what I want. Okay, how are we feeling? We're not just going through the motions. Like, why is this important, guys? Real quick, why is this important? Because we're going to be doing real life applications the next time we meet again. Over sinusoids. Can you think of something that happens all the time in pattern? You go to the beach. Those. Okay, I guess wait. Something with high, something with low. The time. Temperature is also sinusoidal. Temperature is also sinusoidal. So anything that has a pattern has a sinusoidal. You can make it. All right, guys.